Hey, Vlad here, devinsider.com. Welcome to another video. In the previous video, we immersed ourselves into the world of Circe, and today we're going to continue with this exploration and talk about all kinds of ways of creating our own encoders and decoders. This is not going to be the last video about Circe, so let's not waste any more time and get right to it. So this is exactly where we left off. I cleaned it up a little bit. I removed the GitHub example. So basically we're just reading this simple data JSON and we're printing it out. If it's good in green and if it's bad in red, same as in the previous video. Okay, so over here we only have the data, which has this fancy rendering, fancy toString. Apart from that, we basically have only our read JSON from, which is exactly the same. It stayed untouched, and also we have the package object where we just added a couple of helpers. Nothing major. Apart from that, everything is exactly as in the video before. Cool. Now let's talk about codecs. A codec is a blend of two words, encoder and decoder, or technically coder and decoder, but it doesn't matter. In terms of Circe, it's called encoder and decoder, and these are traits. And also, Circe has a trait called codec, which basically mixes in both of them. But it's only there to define codecs more conveniently. Now, so far, meaning in the previous video, our codecs have been derived for us, either with the automatic derivation, which came from circe-generic auto import, or we use this configured JSON codec annotation, which came from an extra model called, well, extras. Now, automatic derivation is a concept of looking at your data structures, understanding its types, understanding its shapes, understanding the, the names of the fields, and then deriving means generating, in our case, codecs. Usually automatic derivation means just deriving implicit instances, but in our case it's deriving implicit instances for these traits, encoder and decoder. And all of this stuff is happening at compile time, and usually it's powered by macros. And automatic derivation is the most convenient way of deriving these instances. However, nothing in this life comes for free, which is exactly the reason why I'm making this video, to show you how to create your own codecs by hand. And there are many ways to do this in Circe. But before that, let's talk about automatic derivation real quick, more specifically about the costs of automatic derivation. Now, in Scala 3, there will be a unified way of deriving instances automatically. However, until then, we're left with a plethora of implementations. Most of them are based on macros, and most of them are based on a library called Shapeless, but there are others. Shapeless is a library that pushes the Scala's type system to its limits, and it's full of dark magic, and it's far from perfect. For instance, it's slow at runtime, which hasn't been a concern for us during this entire data juggling playlist. However, when we talk about JSON, latency might be of a concern. Now, the reason why it's slower is because the instances are actually not derived for your data. Your data is first converted into HLists or coproducts, and the instances are being derived for them. Another issue is that compilation times will suffer, because what is happening is that these instances are not being derived once and put in your companion object, for instance, as we will do manually, for example, in this video. What is happening instead is that they're being derived at call side. So let's say that you have a case class response, for example, and there's an int inside and there's a string inside. Every time you're calling .sjson, macros has insert an instance in there. Now, there are ways to mitigate this, which is also one of the reasons I'm making this video. Yet, another issue that arises from automatic derivation is that the implicit instance, in our case the codec that is being derived for us, might not be the codec that we want, and we're going to see an example of this a bit later in the video. We're going to start almost at the very bottom and implement the codecs almost from scratch. I also considered going even lower, but then I decided that it's really unnecessary. We're not going to re-implement half of Circe over here. So let's begin by removing the import to the automatic derivation, and also because it's not going to compile now, let's also just switch to the compilation instead of rerunning this example. Right, so let me press enter, tilde C, like this. All right, now we need to go and define our codecs ourselves, and maybe actually we will see, we see the exact error message. Couldn't find implicit value for evidence parameter of type decoder. Right, the only thing that we're doing over here is decoding, not encoding. We're gonna improve this example a bit later. Okay, so we have our final case class data. So let's go and have an object data, and inside we're going to implement the encoders and decoders. And for this, we need to import Circe, because this is where they are defined. Import IO Circe, right? So in there's, for example, decoder and so on. Okay, so let's do underscore. So let's go over here. So they're going to be implicit, right? So we're going to do implicit val decoder, and I can type again, implicit val decoder, which is going to be decoder for data with some implementation. And by the way, this should already be enough to compile our example, because we're only using the decoder. However, let's also add the encoder. Okay, so this is going to be the encoder, and this is going to be the encoder like this. All right, so as you already know, there's a trait called decoder, so we can just do new decoder for data like this and just do that, and metals will help us with the implementation. Come on, there we go, apply. And we're also, don't worry about the types for now. We're going to talk about this a bit slower in a second. Okay, let me just finish typing this and let's do the implementation. There we go, this one. There we go. Right, let's see if we ended up having some silly imports. No, we didn't. Cool. As already mentioned, Circe also defines the trait codec, which is basically mixes both of them together. So we, for example, could comment this out. We could rename this to codec and just say over here and over here. We could just say codec and it's still going to compile, right? So if we jump into codec, we're going to see it's just a trait that mixes both of them. Okay, let's go back. The other thing that we will do is we'll also make sure that we're actually using the encoder over here, right? So we're going to add tab and we're going to map to print line our hyphens. Let me actually copy them from here like this. Okay, and let's have another tab and we're just going to do map as JSON pipe print line. Good. Okay, so we're also encoding, and for this we're going to need an import, which is import io.circe.syntax. Okay, let me actually remove this one like this. This should be enough. Yeah, so now we're decoding and now we're encoding, but it's obviously going to throw an exception because we don't have an implementation yet. So let's talk about the implementation. So first one is going to be the decoder, and it's using a thing called hcursor, which is a very low level detail of Circe. So Circe has three different cursors. You know, it has a cursor called just cursor, and it basically allows you to move through your JSON, right? So it allows you to go to a JSON and say, okay, you know, go one field down, or, you know, go into the array and so on. Hcursor is the same thing. It just also maintains the history, and also there is a cursor, right? And a cursor is the same as hcursor, but it also tracks errors for you. But we don't need to care about the, you know, I actually consider to have a separate video just about them, but I figured that most people aren't going to care about this, so I skipped it. So yeah, so let me throw this out. Let me throw this out, and this one as well. Get this compile. Yeah. Okay, great. So now we can just go and define it. So we could, for example, do this. Okay, so we're gonna grab the cursor, right, which is going to be over here. I don't want to be called C, and I want this one to be called data. Okay, so we're gonna grab the cursor and we're gonna say go one field down, right, and it's gonna be called key one, this one. Okay, and after that, just say as string, right, and we're gonna do the same thing for key two, which is going to be over here, and it's going to be int like this, and we're going to do map n apply, right? So map n comes from cats. We already have cats implicits. Okay, so it actually should compile. It doesn't like me. It doesn't like me because it thinks that we're calling this one. I actually want to call data.apply. All right, and now this should be enough. Okay, let's also do the encoders, going the other way around, and we're basically going to start by constructing our JSON completely manually. So we're going to say JSON dot, and it has a bunch of helper methods to construct things, and one of them is the object, right? So what we want is we want to construct exactly the same object as we have over here, and we're doing basically the whole thing manually, right? We're saying key one is going to be a JSON from string data dot key one, and the second thing is going to be over here. There's a comma here. There's a 2 over here, and then we're going to say from int, and that's going to be key 2. And this should already be enough. In fact, we can switch to running again, and we should see exactly the same, you know, decoding and encoding as we had before. So now we're going to just keep going and improve the implementation. But before we do that, let's actually switch back to encoders and decoders instead of using this codec thing, because since Scala 2.12, the SAM types expansion was introduced. So if a trait or an abstract class, it only has one abstract method, which is why it's called SAM, single abstract method, you know, type, then Scala will convert a functional literal straight into this trait. So we need to make sure that we're dealing with traits that have only one function. So let me call this one decoder again. This is going to be decoder, and we're just going to duplicate this line, bring it down like this, close the curly brace over here, call this one encoder, and this one as well, and this one as well, encoder. Okay, so it's exactly the same thing as you have seen before. Okay, so what we can do now is, because we're using SAM types, right, we can just remove this and remove this, right? So that we just have this apply function, right? So we can just say this is going to be a function literal where a cursor comes in, arrow to the right, and we can just remove this entire line, and it's going to behave exactly the same as before. And now there's no function called apply, so now I can actually go and do apply like this, all right? And exactly the same thing over here, remove this part, remove the closing curly brace, and now we can just say, okay, data comes in, and this line is removed, and exactly the same as before. Okay, so this is a lot less to type, and and now we can go and improve this a little bit further. Now there are many ways to do this. Like I don't know, the API is way too flexible. It's kind of hard to remember. Okay, so for example, instead of doing downfield first, we can just go and say get, right? We can just do get, and then we can just specify the type, right, which is string in this case and int in this case, and now we can remove this as part. Okay, so we can do this and that, like this. Come on, what happened there? Okay, that was a comma. All right, so this is exactly the same thing. And now we can actually also go and because behind the scenes it uses the decoder, so we might actually as well go and just use the decoder, right? So we can just do decoder, and then we can do decode string, and we can say at key 1, and over here we can just grab the decoder and say decode int at key 2. Okay, remove these two. It should behave exactly the same. It doesn't, because at this point we're not even using a cursor. So at this point, this is not even a function. This is just a way of combining decoders, right? So we can just remove this cursor entirely, right? So at this point, we're not dealing with it at this low level. And also because we know that the decoders, even the default ones, the ones that are defined inside of Circe, they're available implicitly. We can just go and grab them, right? So over here, instead of dot decode, we can just have a curly brace and the rectangular brace like this, right? So just grab the decoder and and call at on them. Okay, so now we can do exactly the same thing for the encoders, right? So instead of doing JSON.fromString, we can do the same trick as we did before. We can say encoder, and instead of from, we're going to say encode, and the same thing over here, right? So we're going to do encoder, and over here instead of from, we're going to say encode. And by the way, if we jump into them, we're going to see that for something like string, it just goes and does JSON from string. Okay, for something like integers, it's a bit more complicated because sometimes it tries to convert a string into an int. Okay, so over here, if this was a string, behind the scenes, the default decoder would still convert it into an int. Okay, it's very convenient for us. This is also the reason why I didn't want to go like very low level, because I didn't want to implement like these, all of these details. Okay. Right, so we can do the same jump as we did over there. So we can do over here, brace like this and brace like that. I also need to call apply like this. So as you can see, our code keeps improving and improving and improving. And it turns out that, again, Circe is very flexible. It actually comes with even more helpers to do this. So instead of this, we could, for example, just say decoder for product 2. Okay, so every case class, it extends product, and in our case this is a product with 2 fields, so we can just say with product 2 and then just specify the fields. So we're going to do key 1, and then we're going to do key 2, and the same as with map, and we need to pass it the function that would construct and the thing for us, right? So we can just do this instead of that. It's exactly the same thing, and we can do exactly the same thing for the encoders. So let me throw this out. We can do encoder, but the function needs to go the other way around. So we need to say unapply, and do get over here, because unapply actually returns an option. I forgot to remove this guy. There we go. Okay, so as you can see, it gets smaller and smaller. Anyway, if our case class had like another field, we would call, for product 3 and so on. If we jump in there, if it works, come on, it doesn't. All right, maybe we can do there. Maybe we can do for product. Hold on, product decoders. It's probably in there. Come on, why can't I jump in there? Whatever, you get the idea. Now, so far, this is my favorite. However, there is still plenty of ways to, for things to go wrong. For example, every time we add a new field, we need to make sure that we add it over here. Also, it's not really typo safe, right? So if we forget like one thing over here, the whole thing is going to break. Okay. So there are ways to improve this. However, we also get, a lot of flexibility because we're dealing on this level. For example, let's say that key 1 was some sort of ID and you wanted to have a better type for it. So at the JSON level, you don't want to change it, but once it comes into Scala, you want to wrap it into something. In fact, let's do this real quick. So let's go over here, and we're going to have final case class. We're just going to say key 1. So this is basically, we're just tagging the string. Okay, we're going to say extends any val, and we're going to go to object key1. We're going to do the same thing. We're going to say implicit val decoder, which is going to be a decoder for key1 like this, and it's going to be just the decoder for string. Okay, so we can just grab the decoder for string, and then we can map it to apply. Okay, so we just map it into a key. Okay, let's like this, and we can do the same thing for the encoder, implicit val encoder, which is going to be the encoder for key1. It's going to be a function where the key comes in, right? So this is going to be this one, key comes in. Okay, and we're just going to grab the encoder for string, and we're going to call apply with the key dot value. All right, and let's go and use it real quick. Let's go and use it. So we can go, for example, in our data, we're going to say this is not going to be a string. This is going to be key1 like this. Let's see if this is actually enough. And yes, it is. So as you can see over here, this is just a regular string. However, once it goes into Scala, it's going to be key1. Okay, and when it comes out, you know, when it gets encoded, it's a string again, right? So this key1 is completely transparent, right? So obviously, like all the implementations that we had before, they could use this, and this one also can still use this, right? So I'm just saying, like, everything that was before, it gave us more power, but it was like a bit more code. However, this one is a really nice middle ground, and this one doesn't use any macros. It has only the dependency on the main circe module, which is this one. Right, it only needs this one. So yeah, this is a really good middle ground. However, again, it's still not typo safe, and every time we change our data, we also need to remember to change our decoders and encoders. And by the way, over here, some people really like to use the contra map function, which I find confusing, but for encoders, it's kind of straightforward. You just remove this, and instead of apply, you're saying contra map, and instead of k, you're saying underscore. Okay, so this is exactly the same thing. Contra map like this. All right, behaves exactly the same. Okay, so maybe it kind of reads nicely, so it's mirrored a little bit better, right? Over here you have a map, over here you have a contra map. Okay, we actually played a bit with this in the video about function juggling. But again, at all of these levels where we don't use macros, you have like all the flexibility that you want. For example, over here we're just calling apply, right? But this just wants a function that that takes key1 and takes key2, and you can do whatever you want with it, right? So obviously you're going to call apply, with key1, for example, but you can say key2 should be +10, right? So basically we're reading it in properly. Did I have too many? What's happening? Missing parameter type. All right, so this is going to be a string, and this is going to be an int. I wasn't sure that I needed to specify them. Oh yeah, I forgot that we're using key1. Okay, so we actually need to do key1 over here like this. I believe maybe now we don't actually need to specify the types like this and like that. Let's see. No, we still do. All right, so in any case, the point is that you can do whatever you want, right? So we're decoding it properly. So when we're decoding it, I changed the decoder, right? So we're decoding it, we're not decoding it properly. Okay, so 27 comes in, but over here we're doing +10, and therefore when we're encoding back, it's going to be 37 again. Okay, so let's revert that. Let's actually just use apply. What's happening? Apply. There we go. And by the way, in case this wasn't clear in the previous video where we had our data and our sub data, obviously you could just encode or decode just the sub parts. So for example, we could encode like key1. In fact, let's go to the package object and add another helper. Okay, so we're just going to have a function over here which is going to be called round trip. Okay, we're going to use this function quite a bit. Okay, so it's going to need an encoder, and it's also going to need a decoder. Okay, so passing in an a, and what comes out is a decoder dot result of a. And if you remember, decoder dot result is just a I wanted to jump in there and it didn't work. Hold on. Equals, maybe compile it first. Okay, yeah, that's why it didn't compile. So we need to import circe. Let's go. Okay, so the result, this is just a alias for either decoding failure or a. Okay, and the decoding failure extends an arrow, and an arrow extends an exception. Okay, so let's go back over here and implement it real quick. So I just want to say a dot sjson, and we're going to tap it into print line. Good. Let me scroll down a little bit like this. Okay, and we're going to tap as. Remember, we added tap as over here, which uses a by name parameter. So I can do print line, and I don't want to type this hyphen. Where is it? I can just do this. Okay, like this. Just put it over here. Okay, because if we didn't have tap as, we would need to do this. Okay, because we're not dealing with, we don't want to do anything with the parameter. Okay, so we're going to do this, and now we're going to pipe as a. Okay, so this is the decoding, and now we're also, because this is a round trip, we also want to do tap. We're going to do bimap, the same thing as we're doing in our main print line bad and print line good. Okay, so now we can call this thing was an a if I type correctly over here. So we can call this thing was, what's wrong? It's the second error, so it probably doesn't know where sjson comes from. Yeah, so it also needs the circe syntax. Import io.circe.syntax. There we go. Are they sorted? Let's check. Like this. All right. Okay, so basically we can call it with some random a that has an encoder and decoder. We're going to encode it, have a couple of print lines, and then we're going to decode it, have a couple of print lines again. Okay, so we can go to our main, for example, over here, and now I can just call it round trip, and I can give it key one was whatever, and it's going to show me a nice round trip. There we go. Okay, so we see whatever being decoded. No, this one is encoded, right? So this one is encoded and then decoded back. All right, so let's raise the stakes a little bit and use the semi-automatic derivation. So this is a very nice middle ground between what we had so far and the automatic derivation. Okay, because it's faster than the automatic derivation, and it's more typo safe than this thing. Okay, so all we need to do is, I remember before we had io circe generic.auto like this. Now we're just gonna put semi-auto over here. Okay, and what this allows us to do is it allows us to, instead of having like these things and these things, okay, we can just say derive decoder and derive encoder. Okay, so it behaves exactly the same as before. It understands everything, and by the way, it has a type parameter, but we don't need to specify it because we already specified it over here, right? So data. Okay, so this is just a function in there that does it for us, and I believe that this is the derivation that most people use actually in production, because again, it's faster than the automatic derivation, and it's more typo safe than what we had before with these full product methods. But it still has a cost, right? We still lost a little bit of flexibility where we were allowed to do whatever we want with our JSON before it arrives at our at our own ADT. Okay, now this is still a little bit boilerplate, right? So you still it's one line, but this is what most people do in production. Now, I came up actually with a trait that you can mix into this companion object, and you won't even need to do this, and you won't even need to do these imports. I have no idea why Circe doesn't contain this trait. Maybe it actually does, and I just don't know about it. They do the similar thing with the annotation, but the annotations require macros, and we're going to get to that. So let me just go, and I'm going to create a file, and I'm going to call it has JSON codec 4. Okay. .scala. Okay, so before I go and implement it, so what it will allow us to do, it will allow us to do this. It will allow us to do extends has JSON codec for data. Okay, so for this case class data, and it will just do like these two lines for us. Okay, so for now it's not there, so let's comment this out. Okay, let's go and implement it real quick. So let me bring this down because that's how I prefer it. Okay, so we're gonna import io circe. We're gonna import io circe generic decoding derived, come on, help me, derived decoder, and the same thing for encoding, and it's going to be derived as object encoder. Okay, and we're going to do import io circe generic semi-auto, right? So it's still going to do semi-auto. Okay, and now we're seeing like the insides of it, so we're going to do a shapeless lazy. Okay, and we're going to have a trait called has JSON codec for a, like this. Okay, and this trait is going to have the decoder and the encoder. In fact, we can actually go and let me copy paste these two lines. Let me put them over here. Okay, so they're not going to look exactly like this. Okay, so this one is going to have a parameter implicit. I'm going to call it D. It's going to be the lazy derived decoder for a. Okay, and over here we're going to do a similar thing, implicit E, which is a lazy comes from shapeless, as you see over here. Okay, let me just copy paste this thing. Derived encoder for A. Okay, and this is all that we need to this is all that we need to have over here. This is not going to be a val anymore. This is going to be def. Okay, in fact, it's going to be a final. Well, actually, let's not make it final because this way people can still override it if they want. Okay, so let's go over here, and now instead of these two guys, we can just do this one. And because we're doing this, we actually don't need the import for semi-auto anymore. Okay, like this, which is kind of cool, right? So you just mix it in the trade. You don't need to have any circe imports. We have these ones only because we're actually in the main method where we're also doing this stuff. But if this this thing like lives in your own file, then you don't even need any circe imports, which is super cool, I think. All right, now I'm realizing just now that all this time in the previous video and this video, I haven't actually showed you that this whole decoding and encoding also works for ADTs. Okay, so let me actually copy paste this because an ADT is a lot to type. Let me throw this in over here. Okay, so this is a simple ADT, right? The companion object mixes the has.json codec for my ADT, okay, and just a couple of examples, right? So we have a case object, my singleton 1, my singleton 2, and we have my product, was A and B, which is string and int, and also we're doing local date and local date time so that I can show you how they are encoded. Okay, so now let's go and do the instances. Let me just copy paste them as well because I just don't want to type this stuff. It's just to show you that this works. Okay, so note it's very important that these codecs that we have over here, they're working only for this type. They're not working for this type. With automatic derivation, you would have instances for literally everything. Okay, but over here you need to be specific that you're doing my ADT. Okay, so if we go and if we do. Let me actually copy paste this as well. It's so much to type. I don't want to waste your time. Okay, so we're just basically printing out a bunch of these round trips. This is weird. When I was preparing for this video, this thing worked. Anyway, let's continue. So circe actually comes with an annotation that does that thing that I was just doing sort of manually. And for this, we need to import circe generic again. Okay, so now instead of mixing this thing into the object, we can just have an annotation over here. We can just say add JSON codec. Okay, let me actually copy this one because we're going to need it for data as well. And now we can remove this one. Let's see if that's going to work. All right, compiling. It seems like it's working better. Yeah, okay, so this one actually worked. Just as a reminder, for this one to work, you need to go to your build, and if you're using Scala 2.13, then you need to have this macro annotations, and if this compiler flag, and if you're using Scala 2.12, then you need the macro paradise plugin. Okay, 2.12, or I think for 2.11 it's also going to work. If 2.11 is even still supported by circe, maybe the older version supported, I'm not sure. In any case, so now you have this annotation. Now we can throw this guy out. Okay, and we can throw this guy out as well. Let me actually go through this example real quick because I just copy pasted it and it was it was way too quick. Okay, so let's see. Okay, so this was our JSON. All right, so this is our instance 1, and this is how it's going to be encoded into JSON. It's going to be just it's going to be an object which is going to contain another object with the key my singleton 1. And the value is going to be nothing because because it's an object. Okay, and the way it's going to be decoded back is going to be my singleton 1, which is the object. Is it even a case object? Did I make it? Yeah, it's case object. That's why we have the previous toString. Same thing for my singleton 2 over here. And this is going to be this one. Okay, so it's going to be my product 1 hello world 1337. This is how it's going to be encoded into JSON. My product 1 is going to be the name of the object, and the way it's decoded is pretty straightforward. And this is how the date times are going to be encoded. They're just becoming basically strings, and this is how they're formatted. I believe that this is the ISO formatting. Just note that when it's getting decoded back, the default time zone is used. In fact, if we actually go real quick, and if we do having the user dot what is it called, time zone, we can say UTC like this, and you should see something different. So let's run it, and there we go. Now you see the actual UTC time. So over here in my VS Code you see the local time, which is 10:41, and this is the UTC time, which is 13:41. All right, let me actually revert that real quick. just start SPT like this. So let's run it. And if you remember from the previous video, we actually had yet another annotation in there that allowed us to rename fields and to change the casing of the fields. Okay, so we can go and say, instead of JSON codec, we need to import generic extras like this. In fact, we don't need the generic anymore. And now instead of at JSON codec, we can say configured JSON codec. And if you remember, in our package object, we still have the configuration for it. So the configuration is this one, and we say with the snake case member names. In fact, let's just for fun, let's go and change it to something else. Let's do with, so let's do with kebab case, right? And remember that we have, we have this thing for the constructor names and for the member names. For our example, the member names is going to be enough. Okay, so we can go and for example, over here, we can say that this is going to be key one kebab case. Let me have a bit more space like this. Kebab case, okay, and we can go into our main over here, and we can say over here that key one is going to be called kebab case. Okay, so technically we're using camel case over here, which is what you want. We already talked about this in the previous video. In fact, I'm not actually sure that we're going to do anything with this ADT anymore. Let me throw it out. Let me comment it out for now. And yeah, let's comment them out as well, and these guys as well. All right, like this, because this way I think it will be a little bit faster to compile, and also we're gonna see, maybe I can create a bit more space so that we see the entire thing. Like this. There we go. Now, I'm not sure if I showed it to you actually in the previous video, but this import that we're using right now, this generic extras, it doesn't come only with this annotation. It actually has a couple of more. So, for example, it can allow us to completely rename the key2 over here. Okay, so for example, let's say we want the variable to be called key2, but the actual thing is called something different. So, for example, it could be called key2 with different name like this. Let me actually copy this. Key2 is different name. Let me have a bit more space over there. Okay, so over here we can say before the key2 we can say at JSON key and just pass it in like this. Okay, so basically it's going to know that inside of your JSON it's called like this. What's wrong? Oh, I forgot to save the file. There we go. So now that it's saved, it says key2 with different name over here, right? So when it comes out, it's called like this. When it comes in, it's getting renamed to key2. Very convenient. I would rarely use this because I would usually, I'm sure there are occasions where you actually need this, but yeah, for now, let's actually revert it. I don't like it. Key2 and key2 over here, like this and like this. Okay, so yeah, so now we're pretty much done where we arrived back at the automatic derivation. Remember that for some reason automatic derivation in Circe, in contrast to something like pure config, actually doesn't allow you to rename fields. So before we switch back, we actually need to fix this one. So it's going to be key1 kebab case like this. Let me scroll down over here. All right, so we can do generic auto like this. Now we can throw out the extras, and now we don't need the annotations like this. And yeah, that's pretty much all we need to do. This is what we had in the very beginning. We arrived at the automatic derivation, which is the simplest one because you don't need to touch your data at all. However, every time at call side, this instance is going to be derived for us. Now, remember in the beginning of the video, I also said that automatic derivation sometimes doesn't derive the codecs that we need. And let me show you an example for this. Let me have another the key over here. Let's do key 3. And let's do, I don't know, 1337, okay? And I'm only doing this because once I'm going to add the third parameter over here, Scala FMT is going to spread these 3 arguments across 3 lines, and that's why I'm doing it. Okay, so our example is going to be that we want to read this thing into an either, right? So in our example, it's going to be either a string or an integer. Okay, so if we do this, either string or an int like this, as you can see, Scala FMT broke it into pieces. Okay, but it's not going to work because this is not how automatic derivation works. In fact, in our case, automatic derivation didn't do anything. But I believe, actually, I thought it would actually derive the codec for us. So I wanted to demonstrate that it's going to derive the wrong codec for you. In this case, we actually kind of got lucky, and it just failed to derive the codec for us. However, the point is that we can go and we can define our own. In fact, that's weird. I'm pretty confident that it should have that it should have derived the codec. Okay, I have no idea what is happening. Hold on, let me clean real quick. Let me run again. No, it still doesn't know how to do this. I wonder why. Let me also fix key1 just to be sure that it's not something weird. Okay, over here, key1. We don't need these. Column like that. I really have no idea why it can't do that. It was able to do this. In any case, so by I wanted to say that by default it does this, but it turns out that by default it doesn't do anything. I have no idea what changed in my setup between the preparation and the actually showing it to you. Hey guys, after I finished editing this video, I realized that this mistake that we did in the has-json codec for was actually ruining the entire video, and I actually considered re-recording the entire thing, but then I realized that it should be enough to just re-record this tiny part where I basically fix this mistakes and show you a couple of things. So this is an entirely new project where I recreated only the parts that we need. So we still have the data.json, which has the simple thing in the build file. We don't have anything fancy. We just have the core generic parser, and the core we're not even using the generic the generic-extras module. All right, so in our package object we're still having a bunch of helpers. So we still have pipe tab and tab as. We have print line good, print line bad. By the way, I actually forgot to point this to console.error, which is not mandatory, but it's it's a nice touch. And we also have print line hyphens, which help me to print out the hyphens, and we have the round trip over here. I don't need this thing. All right. So also in the has-json codec 4, well, this is the mistake that I mentioned. Like somehow I left the data over here after copy pasting, and this is why it caused so many issues. All right. So let me open the main method, and in the main method, as you can see, it's only like 77 lines. All right, so let me put data.json over here like this. All right, so as you can see, we have our data same as before, and the object data mixes in my trait has-json codec 4, and the same like in the in the actual video that you're watching right now, it actually still worked out just fine because we're using data, and this is still data. However, when I was playing with my ADT, it obviously broke because it was returning as the codec for data and not for A. Okay, so I went and I recreated the whole thing. So we have our main over here. We're reading this JSON in, okay, and we're doing the typical print lines. So let me go and scroll up. So this is it's coming in. Okay, this is the decoded one. Okay, and then at the bottom I did the same thing for my ADT, and as you can see, we're not using any any annotations, anything weird. So I'm just mixing this thing into the package object, and as you can see, the rendering of all of these instances, it's it works out just fine. And the last thing that this one mistake broke in this entire video was that either, right? So usually when I record my videos and I see an error message in the console, I usually don't read it. I should, but I usually don't read it because usually it's just a typo somewhere, right? And I just quickly compare it with the script, and I didn't even see that the entire problem was not coming from either. It was actually coming from this has-json codec 4. All right. So if I actually go over here and I just play with either a little bit and I use the generic auto, it actually generates the codecs, but none of them are actually the ones that we need. And this is what I wanted to show you before we went and implemented our own. So I wanted to show you that, first of all, if you're doing auto, it doesn't only generate the codec for either, it actually generates the codec for all the subclasses as well. This is what I meant was my ADT over here, right? So we have my ADT. Now, if we're mixing this thing in, we only have the codecs for this type. We don't have it for this type or this type or this type. Okay, this is why I was very specific and I said that we need this type over here. As soon as I remove this, it shouldn't compile because it's not going to have the codec for it. Yes, and this is exactly what is happening right now. Okay, and then I wanted to show you that automatic generation doesn't always generate what you need. However, it generates it for both the types, for either and for right, and in none of those cases it actually generates what we want. So if you just go in for the right, it will generate this, and if you go in for either, it will generate this. Okay, but in none of these cases it's what we want. Okay, so now you can go and continue watching the video, and you're going to see how we're going to define our own, which is going to do exactly what we want. All right. have fun. In any case, we can actually go to our package object and we can define our own decoder and encoder for either. Okay, so we can go over here and we can say implicit def, and it's going to be the either decoder. In fact, yeah, I call it capital because either is a type. Okay, so it's going to be an either of L and R, and both of them are going to need the decoder. Okay, they're going to need the decoder, and this one is also going to need the decoder. Okay, and we're going to do decoder of either whatever is on the left or whatever is on the right. And the implementation for it is going to be, we're just going to grab the decoder for the left side, and we're going to map it to left.apply. And there's a method called OR, which allows us to concatenate the decoders. Remember, for the other one, we were just toppling them and doing like map and or something. And for this one, we can do OR. Okay, so it's going to try the left one, then it's going to fail to the right one. Okay, so we're going to do decoder R map right dot apply. Let's see if we have all the imports in place. And something is wrong with the curly braces. Hold up. Was the rectangular braces. There we go. All right. Cool. So now we can do the same thing for the encoder. And we're going to paste this in. Everywhere we say decoder, we're going to say encoder. Whoops, too much. Encoder. Okay. The implementation is clearly going to be a little bit different. So we're going to have just a pattern match over here, right? So again, we're using the SAM expansion. So we're going to give it the partial function, and it's going to convert this into an instance of encoder. It's a very beautiful code, actually. So we're going to do left L, grab the encoder for L, call apply on it. Do the same thing for right R, and R, and R over here. Okay, and I believe this is actually enough to be able to read this integer, so it understood this, that this needs to go into the right one over here, and if this was a string, was whatever, it would actually read this into a left. Okay, now in very, very rare occasions it actually happens that you have the same type on both sides. So let's say that we had strings on both sides. Okay, then it's always going to read this into the left one because of the because of the way that our implementation is treating it, right? So this is a bit arbitrary, but usually either is right bias. So why don't we flip them? Okay, so let's do this one first. Let's do the right one first and then the left one. Okay, so now, it's always going to be read into the right one. But, it's a very, very rare case that you're going to have the same type on both sides anyway. Awesome. Now, we're pretty much done for today. This is not going to be the last video about Circe. There might be more videos, and yes, plural. I know it's crazy. Maybe. I don't know. Maybe there's going to be only one more. Now, before I leave, allow me to give you a couple of examples. The first one is that what I usually do is I'm defaulting to this add configured JSON codec annotation, and only if I need something extra, then I'm falling back to one of these solutions that I showed you. And secondly, please be very careful with any kind of generators. So what I usually do in my project is that I have my domain entity somewhere at the very, very top, and the JSON encoders and decoders are not defined for them. What I do is that once these entities reach my boundary to the delivery mechanism of my application, which is usually going to be the web in case of JSON, over there I'm defining my case classes again, and then I'm using something like Chimney to transform the domain models into this JSON layer. Okay, and only then I'm having codecs for them. And the reason is quite simple, because when I'm coding in my when I'm programming in my domain model layer, I want to be able to refactor my code with ease without being worried that I'm breaking some JSON API, right? Because it's gonna be simple, right? You can rename a variable, but all of a sudden all your clients are broken, and I don't want that. So I know that it's going to cost me a teeny tiny bit of latency, and I know that it's not as convenient maybe, but it helps me sleep better at night. All right, and with that said, that's all I got for you today. It's been Vlad, devinside.com. Don't forget to like this video if you did, subscribe if you want to improve the developer inside you, and if you learned something today, consider supporting me on Patreon and thus watch my videos before everyone else. And most importantly, take care.